Okay, so we'll start with the first question. So, good evening, everyone. Welcome to all. So today we are going to talk about week 7 assignment. Okay, so question 1 is, so let gamma be a piecewise smooth curve in in the complex plane C, and let h be a function which is continuous on the trace of gamma. Be a continue. Okay, be a so be a continuous function on gamma, and let k be a positive integer. So define a function h on open set omega is equals to c minus omega by h of z is equals to integral over gamma h of xi minus z to the power k d psi. Okay, so prove or disprove that h is a holomorphic function and whose and so the derivative is given by k integral over gamma h of xi minus z to the power k plus 1 d psi. Okay, so this is the first problem. We will do this one. Okay, the solution of one. Okay, so so this I will prove for, I mean, if it is k is equals to 1 and 2, and then you can prove it by induction. Okay, so 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 we'll prove for k equals to 1. Let z naught belongs to omega. So our claim is this way. So the claim is limit z tends to z naught h of z minus h of z naught upon z minus z naught. This is basically exist, okay, which is equals to h of xi d xi and xi minus z naught square. Okay, or so this is equivalent to proving that equivalently what we need to prove. So a modulus of hz minus h of z naught upon z minus z naught minus integral over gamma h of xi upon xi minus z naught square d xi. This tends to 0 as uh, z tends to z naught. Okay, I hope it is clear. Okay, so fix some r positive and s positive so that this ball z naught of radius 2r is contained in, so this is basically contained in maybe omega, and gamma is contained in this ball. Yes, okay. I'll just tell you how this looks like. So basically, so this is your point z naught. Okay, and let us say this is your any curve gamma. Okay, so this gamma is basically in this one, and so if you make a radius 2r ball, so this is this, and let us say this is radius 2r. Okay, so this is your 2r. Okay, so what we're going to do is, so for z not equals to z naught, we compute the following. Okay, so it is, so I'll write down here, so h z minus h of z naught upon z minus z naught. So according to definition, what is this one? So 1 upon z minus z naught integral over gamma h of xi minus z minus h of xi upon xi minus z naught. Okay, which is thing with dz. Okay, so this also you can write 1 upon z minus z naught integral over gamma h of xi, you can take common out, so 1 upon xi minus z minus 1 upon xi minus z naught, so dz. Okay, and this is 1 upon z minus z naught integral over gamma h of xi, and this is basically, so xi minus z, so this is z minus z naught upon xi minus z into xi minus z naught. Okay, and this is dxi. So this okay, so this I mean this z minus z naught will get cancelled out, so this is basically integral over gamma h of xi upon xi minus z into xi minus z naught. Okay, now what we need to calculate, so we need to calculate this quantity here. Okay, so now we will calculate this one. So basically h of z minus h of z naught upon z minus z naught minus integral over gamma h of xi upon xi minus z naught square dxi. We'll calculate this thing. Okay, so this will be equals to, this is integral over gamma h of xi, so this is dxi, xi minus z into xi minus z naught dxi minus integral over gamma h of xi minus z naught square dxi. Okay, and this will be in the this one. So this whole integral will become integral over gamma h of xi, okay, and once you do this one, so this will be so this will be xi minus z into xi minus z naught square. So, and here it will be xi minus z naught minus xi minus z, okay, and dxi. And this is nothing but integral over gamma h of xi. So this is again z minus z naught. So this is z minus z naught and xi minus z into xi minus z naught square d of xi. Okay. So now you can take out this modulus of z minus z naught outside, and this is now h of xi upon xi minus z into xi minus z naught square dxi. Okay, now so here we have to do this thing now. So observe that here xi is on the curve. So this xi is on, let me write it down here. So xi is on basically the curve gamma. Okay, clear? And if z belongs to this ball z naught comma r, so star means z naught is not included, then modulus of xi minus z naught is greater than equals to r, and modulus of xi minus z is greater than equals to r. Okay, like you can see here, if so xi is on this gamma, okay, somewhere here, okay, and if z belongs to somewhere in this ball, okay, with this r radius ball, so it means that this is r, so this is 2r, means this is r. So if z is somewhere here, okay, let us say, so this is your z. If z is somewhere here, then z minus xi will always be greater than equals to r. Okay, is it clear? Hello? Yeah, so with this in mind, this is less than and equals to, so xi minus z and xi minus z naught, this will be r cube, so this will be mod z, okay, so mod z minus z naught upon r cube h of xi dxi. Okay, as z tends to z naught, okay, this, so right hand side tends to 0. Okay, so this implies that this thing, as z tends to z minus z naught, this implies that limit z tends to z naught, h of z minus h of z naught upon z minus z naught is nothing but integral over gamma h of xi minus z naught square dz. So I hope this is clear. So this is quite an important thing. So again, you can prove it for k equals to 2, and then you can move ahead via induction. Okay, so I hope this is clear. Any doubt in this one? Anyone, any doubt?
So they have taken another ball of radius, yes, but we does not use the here.
Where?
We have used ball here.
No, so yeah, so basically this xi is because to show that this gamma is in this one, this big ball. I mean we can bound the gamma.
Whether it is it not or the center is 0, sir.
Which one?
For the ball gamma contained in V of 0, s or the z not, s.
No, 0 comma s.
Okay.
Okay, so I mean it is, since gamma is a compact set, so we can bound it. So basically gamma is what? Gamma is a function from 0, 1 to c. So this is a continuous function. So it has to be compact set in C. Okay. So we can bound it this trace of the gamma. Is it clear? Any other doubt? Okay, then we will move ahead. So similarly, you can prove it for k equals to 2. So let me write it down for k is equals to 2. So what we have to prove now? So, so in a similar way we compute. So similar way we compute. So now k is equals to 2. So so in the definition of hz we have to put 2. Okay. So this is now hz minus h of z naught upon z minus z naught is equals to 1 upon z minus z naught integral over gamma h of xi, and so this is 1 upon xi minus z whole square minus 1 upon xi minus z naught whole square. Is it so h of z minus s of z naught, so it's a square. Yeah, so this is fine. Okay, and this we will get as so integral over gamma. Now this is xi square minus 2 xi z naught plus z naught square minus xi square plus 2 xi z plus minus. Is it okay? Square upon xi minus z naught square sj dxi. So I hope this one is okay. So square minus 2 xi z naught plus z square minus j square. Yeah. So okay. Okay. So this is 1 upon z minus z naught. Something will get cancelled out. Okay. So what we will get? So 2 xi z minus z naught plus z naught square minus z into z naught plus z. Okay, so xi minus z whole square xi minus z naught square dxi. Okay, and this is if you take z minus z naught, so it will be 2 xi, so this will get cancelled out, and this will be 2 xi minus z minus z naught h of xi, and xi minus z square, xi minus z naught square. Okay, now again you need to calculate hz minus h of z naught upon z minus z naught with minus 2 integral over gamma h of xi d xi upon xi minus z naught cube. Okay, so this thing we need to calculate. So what is this? This we will get it as integral over gamma h of xi. This whole thing we will get 2 xi minus z naught upon xi minus z naught whole square, xi minus z naught whole square, 2 upon xi minus z naught whole cube, and this is d xi. Okay, so again z minus z naught integral over gamma 3 xi minus 2z minus z naught into h xi upon xi minus, wait a minute, this would be z, I guess. Okay, so xi minus z square into xi minus z naught cube. Okay, so this we will get. So basically I have done the calculation, so that's why I'm writing here. You can go through this one. Okay, so again with the same thing, if so with the construction, the kind of construction we have done, if z naught belongs to this pole and xi is on omega, then xi minus z naught is greater than equals to r, and xi minus z is greater than equals to r. Okay, so now with this one also, so 3 xi minus 2z minus z naught is basically equals to 3 xi minus 2z, just write minus 2z naught plus wait a minute, so plus 2z naught minus 3z naught. Okay, which is nothing but, so 3 xi minus 2z minus z naught minus 3z naught. Okay, this we can write it as 3 modulus of psi plus 2 modulus of z minus z naught minus 3z naught. Now here we will use this mod of xi. Okay, so mod of xi will be less than s. Okay, so this is basically 3s plus 2r plus 3 mod z naught. Okay, and let us say this is some constant c. Okay, so modulus of hz minus h of z naught upon z minus z naught minus 2 into integral gamma h of xi d xi, xi minus z naught whole cube. This is nothing but c into mod z minus z naught upon r cube integral over gamma h of xi mod d xi. Okay, now again as z tends to z naught, this thing will right hand side tends to 0. Okay, so this implies your h dash z is nothing but 2 integral over gamma h of xi upon xi minus z naught whole cube dz. Okay, so this is done. So here we have used the xi. This you can understand, no? So here we have used this term s. So any doubt? Any doubt, anyone? Okay, so if no doubt, I will move ahead. Let me see the next problem. Okay, so problem 2. Okay, so compute the integral. Compute 1 upon 2 pi iota integral over gamma z upon 4 plus z square dz over the curve gamma such that 0 comma 1 to c gamma of t is basically r e to the power 2 pi iota t. Okay, so for, let us say, for r greater than 2. Okay, so 1 upon 2 pi I, let us say this is I, capital I, integral over gamma z upon 4 plus z square dz. So, so this will be equals to 1 upon 2 pi I integral over z, sorry, integral over gamma z upon z plus 2I into z minus 2I into dz. Okay, let me just check. Okay, so this is 1 upon 2 pi I and 1 by 2 integral over gamma. This is 1 upon z plus 2I plus 1 upon z minus 2I. This is dz. Okay, and so 1 upon 4 pi I integral over gamma dz upon z plus 2I plus integral over gamma dz upon z minus 2I. So now what would be the integral? By Cauchy integral formula? By Cauchy integral formula. So what is the integral? So it is 1 upon 4 pi I and both the integrals are 2 pi I plus 2 pi I. Okay, this is nothing but, is it clear? Any doubt in this one? So this is just by the Cauchy integral formula. Is it clear? If you have any doubt, you can just ask me. Yes, Mina? Any doubt? Okay. Let's just see the next question. So, so let us denote. So let us denote the space of all holomorphic function on the unit disk. So unit disk everyone know. So this is nothing but z belongs to C such that mod z is less than 1. Okay. So this is the space of all holomorphic function on the unit disk. Okay, such that f is holomorphic. Okay. So basically this HD is a vector space with the so under the addition and scalar multiplication. Okay, so these are the two operations: addition, scalar multiplication. Okay, so for any z belongs to the unit disk, define the set sz is basically equals to f belongs to hd such that f of z is equals to 0. So just see this one sz for each z. Okay. Okay, wait. So I have to create a new meeting. Just wait. Create it. Okay, so out of 1 hour, please join with this meeting link. Okay. So everyone, please see the chat box. After 1 hour, please join with that meeting link. Okay. So everyone observe that this is a subspace of HT. Is it true or can you verify this one? Observe that SZ is a subspace of HD. Okay. Clear? So let Q denote the subset of D, subset of this unit is D of those complex numbers whose real and imaginary part are rational numbers. Okay. So now the question is, okay, so let us define this new set S. Okay, which is nothing but Z belongs to this set Q intersection of SZ. Okay, so the question is, what is the dimension of S? Okay, so let us see the solution. So basically, what is this set S? So you take any rational number, okay, define the set Sj and take the intersection of all those things. Okay, so basically Q is what? So Q is Z is equals to X plus IY belongs to D such that x comma y belongs to Q. Okay, so let us see. So basically, what is Sz for a fixed z? So Sz is basically a collection of functions. Okay, so let us see if any function f belongs to S, that is f belongs to Sz for every z belongs to Q. Okay, this implies if f belongs to Sz, what does it mean? Means f vanishes at z. Okay, so it means that f of z is equals to 0 for every z belongs to Q. Okay, and basically f is from where to where? D to C holomorphic. Okay, now the set Q has a limit point in D, isn't it? So f is holomorphic and the set of zeros of f is the set of all rational numbers in D. Okay, real and imaginary part. So now this uh, the set Q has a limit point in D. Therefore, 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 I mean, yeah, what should be there? Hello. So therefore, by identity theorem, f is identically equals to 0 in D. Okay. So this implies S is what? A singleton zero set. That is, so dimension of S is equals to 0. So is it clear? Any doubt, anyone? Is it clear to everyone? Okay, so let us move towards the next problem. Okay, so next question is, so I think this is question 4. Okay, so suppose f such that omega to C is holomorphic, and gamma, so basically gamma such that 0 comma 2 pi to C, so gamma of t is equals to e to the power iota t. So this is basically unit circle. Okay, so which of the statements following statements are true? Okay, so first thing is, so I should write something else here. Okay. So this is kind of okay. So let let this D closure is basically is contained in contained in omega. Okay, so now which of the following statements are true? First statement is, if integral fz z to the power n dz is equals to 0 for every natural number n, okay, then f of minus z is basically minus of f sub z for every z belongs to, for every z belongs to this d. Second statement is, if fz upon z to the power n dz is equals to 0 for every natural number n, then f of minus z is equals to f of z for every z belongs to d. Third thing is, if integral over gamma fz upon z to the power n dz is equals to 0 for every odd natural number, then oh, sorry, so this I should write for every n. So this is even for every even natural number, okay, and this is for every odd natural number, then f of minus z is equals to f of z. And similarly, fourth one is, if integral over gamma fz upon z to the power n dz is 0 for every odd natural number, then f of minus z is minus f of z. Okay. Fifth one is, if integral over gamma f of z upon z to the power n dz is 0 for every even for every sorry for every so for every natural number n, then f is identically 0. So this is the question. Okay, so let us see the solution of this one. Okay, so by Cauchy integral formula, what do we have? 2 pi I f n minus 1 f derivative upon z to the power n dz. Okay, so this is 1. Okay, so if 1 is 0 for every even natural number, okay, so if integral gamma fz z to the power n dz is 0 for every even n belongs to natural number, then so suppose this is 0 for n equals to 2, okay, or n equals to 4. So what does it mean? This implies that fn, so this is fn 0 is 0 for every odd natural number, isn't it? and since f of z is basically equals to n equals to 0 to infinity a n z to the power n. Okay, so if we take f of minus z, which is what, so it's an n equals to 0 to infinity, so a n is what, where a n is fn 0 upon n factorial. Okay, so this is minus 1 to the power n a n z to the power n. Okay, so suppose if n is even, okay, so this an is fine and this z square will be positive and this will also be positive, but once n is odd, so only thing which makes this minus sign minus 1 to the power n is for odd n, but for odd n an is 0, so this whole term is 0. It means that this is nothing but f of z. Okay, so I hope this is clear. So f of minus z is f of z if this is true, this equation 1 is true for every even n. Okay, so this one is true, second one, no, first one is false. Is it clear? So this is clear. Now if integral over gamma fz upon z to the power n dz is equals to 0 for every odd natural number n. Okay, so what we will get, so in this case we will get that similarly an is 0 for every even n, even natural number n. Okay, and this implies that f of minus z is basically minus f of z. Okay, so just wait. Just wait a minute, I have to save the links. So, so for every odd natural number, so this should happen. So fourth one is true, third one is incorrect, isn't it? Okay, so fifth one is, so if it means that an is 0, it means that f n minus 1 0 is 0 for every natural number n. Okay, and this implies an is 0. Okay, for every n, and this is again will imply fn 0 is 0 for every natural number n. Okay, and this will imply that f is 0 by identity theorem. Is it clear? So the next thing is, so the next question is, I think this fifth one. This is question number 5. So, so let f is basically u plus iv be an entire function. So then is which of the following is this are true? Okay, so the first thing is, if u of z is less than equals to 0 for every z, then f is constant. Okay, second thing is, if if f of z plus 1 is equals to f of z, and f of z plus I is equals to f of z for every z belongs to C, then f is constant. Okay, third option is, just let me see the third option. So if f is bounded on every horizontal strip, then f is constant. Okay, fourth option is, if f is bounded on every vertical strip, then f is constant. Okay, fifth option is, f of c is dense in C. So I am audible, isn't it? Yeah, so okay, so solution. Okay, first let us see the one. So consider gz is equals to, let gz is equals to e to the power fz. This is e to the power u into e to the power iv. Okay, so mod of gz is what? E to the power u. Okay, and basically u is less than equals to 0. So what would be this e? So u is less than equals to 0. So this is less than equals to 1, since u is less than equals to 0. Is it clear? So g is entire and bounded. So by Liouville's theorem, g is constant. Okay, so g is constant means that is g dash z is equals to 0. What is z? So this implies f dash z e to the power fz is 0. So since e to the power fz is never 0, f dash z has to be throughout 0. Okay, so this implies f dash is angle equals to 0, and this implies f is constant. Okay, so option 1 is clear. Option 2, Okay, so option 2 is on this one. So f of z plus 1 and okay. So let f be an entire function such that f of z plus 1 is equals to f of z and f of z plus I iota is equals to f of z for every z belongs to C. Okay, so basically, okay, so consider this thing. Okay, 1 0, so this is your iota and this is your 1 plus iota. Okay, so this we will make this a square. I hope this looks like square. Okay, so this is your square S. Okay, now claim is, so the claim is basically f of C is f of S. Okay, so this is the claim. So how do we prove this one? So any z belongs to C. So see, this 1 and I are linearly independent. Okay, so this will work for any two linearly, I mean z1 and z2 linearly independent. So at the place of 1, if I keep z1, and the place of iota if I keep z2, and then linearly independent, then this proof will work. So these are linearly independent. So C is a vector space over R. Okay, so two-dimensional. Okay, so this we will write it as z is equals to x plus iota plus y into iota. Okay, so this is clear. Okay, so where x comma y belongs to R. Okay, so now x is basically a plus n. So a is in 0 to 1. Okay, so any real number can be written like this, a plus 1, no, so a plus n. So just wait. Yeah, so okay, let me see later on. I will. So a plus m, sorry, this would be, b plus m. Okay, so f of z is basically equals to, okay, so here n comma m is in teaser. Okay, so now it is fine, isn't it? Yeah, so f of z is a plus n plus b plus m into iota. Okay, so observe that, let me write it down here with different color. So f of x plus 1 plus iota y is equals to f of x plus iota y, isn't it? By this rule. So f of x plus, okay, so, so f of x plus iy is equals to f of x plus iy plus 1 with this one. So this will be same. Okay, this implies that f of x plus n plus iota y, this is also f of x plus iy, isn't it? Up to this clear? Everything is clear? So this will also hold f of x plus n plus iota y. Any doubt? This is not clear? Just let me know. Similarly, f of x plus iota y plus m is basically f of x plus iy. Okay, so this is basically, I hope I'm audible. Yeah, yeah. So how we are getting this one? So basically x plus n plus iota y. So this see. So basically x plus 1. So this will hold for every natural number n, or any, so every integer nz belongs. Okay, so f of x plus iy plus 1 is equals to f of x plus iy. Okay, okay, then x plus 1 plus iy is again a complex number. If you add 1, then it is f of x. Okay, so here let me write it down, so the details. Okay, so f of x plus iy plus 1 is equals to f of x plus y by the assumption. Okay, and this is f of x plus 1 plus iy. Okay, this will be what? F of x plus 1 plus iy plus 1. This we can write. So now consider this one as z. Okay, so z plus 1 is equals to f of z. Okay, this one is already equals to f of x plus iy. And what is this? F of x plus iy plus 2. Okay, similarly you can prove it for any natural number n. Okay, so this is what I have written, x plus n plus iy. Okay, so this is just for the explanation. Okay, so now this we can write it as f of z is equals to f of a plus b plus m into iota, and now this one we can write it as f of a plus iota b. Okay, and this a plus iota b will be f of s. So basically a runs in 0 to 1, b runs in 0 to 1, f of z. Since s is compact, f of s is basically bounded. So this implies modulus of f of z is less than equals to m for every z belongs to C. So it is entire bounded, implies f is constant. This is by, is it okay? Okay, let's just see the third and fourth option. So solution 3. So it is f is bounded on every horizontal strip, and f is bounded on every vertical strip. Can you go through it again? Okay, so let f be an entire function. So f of z plus 1 is equals to f of z, and f of z plus I is equals to f of z for every z belongs to C. Now our claim is f of C. So the range of f basically depends upon what is the range of f on C, on S. Okay, on this square, whatever we are getting. Okay, so any z belongs to C can be written like this. Okay, this is the vector space property. So they are spanning it. Now x is equals to a plus n. where a is 0. So any x can be written like this, where n comma n is any integer, and any y can be written like this, where you keep a is in 0 to 1 and b is in 0 to 1. Up to this, is it clear? Now what is f of z? So f of, so this is x, so f of z is basically, okay, so okay, so f, okay, so f of z is basically f of x plus iy. Okay, so x is a plus n, y is b plus m. Now a plus n plus b plus m I. Okay, so now consider this one. Okay, so use this one, x plus n. Okay, and consider whole this thing as y. Okay, so x, so a, you let x, so x plus n plus iy, so it will be f of a plus b plus m into I with this one. Okay, so you let this is your x, sorry, this a is at x. Okay, so x plus n plus iy, x plus n plus iy is basically equals to f of x plus iy. So this is f of a plus b plus mi. Now again use this one here, you will get f of a plus ib. So any z, so f of z is nothing but f of a plus ib, where a plus ib is what? Any element in this one. A is in this one and b is in this one, so it will be somewhere in this one only. Okay, so what we have done, we have restricted the range of f on the s. Now since s is compact, f of s is bounded, and this follows by Lewis theorem. Is it clear? Swami? Sorry, I did not understand this one. Values are being repeated. Yeah, I mean, what we are doing is, you take any z. Let us take z is equals to 100 plus 200 iota. Okay, so now for this z, image of this z can be found as an image of a point in S. Okay, this is what we have proved. For any z, the image of f of z is basically equals to f of s. Wait a minute, this should be something. So here I have to write. So let us say f of let us say xi, where xi belongs to s. Okay, so xi is basically a plus ib. Okay, this xi belongs to s. Yeah, so it is kind of periodic function. So I hope it is clear. Is it okay, Swami? Okay, so I will move ahead. So we will see the vertical strip and horizontal strip question option. So let us take f of z is equals to e to the power z. Okay, so you take any vertical strip. So vertical strip means z belongs to C. The real part of z is between A and B. Okay, that is, it is kind of this thing. Okay, now e to the power z is what? So fz is equals to e to the power x into e to the power iota y. Okay, so this is kind of, this implies modulus of f of z is less than e to the power x. Okay, and this e to the power x is bounded. Okay, so where x is in between a to b, so this implies mod of f is bounded. but f is not constant. Okay. Similarly, you can take f of z is equals to e to the power iota z for horizontal strip. Okay. So these two options are not correct. So one is correct, second is correct, third is not correct, fourth is not correct. Let us see if C is dense in C. Okay. So this is option 5. Okay. So we need to check whether f of C is dense in C or not. So let f is f is a non-constant. Okay, so here I should write if f is non-constant. Otherwise, you can take any constant function. If f is non-constant, then f of C is dense in C. So let f be an so let f be so let f be a non-constant function. Okay. So assume its image, that is f of C, is not dense in C. So there is a property of denseness which says that there exists a ball which does not intersect with f of C. So that is, there exists a ball with center at somewhere and radius some r in C, such that f of C intersection with this ball is equals to phi. So that is f of z minus z naught is basically greater than equals to r for every z belongs to C. Okay. Now consider the function g such that C to C defined by g of z is equals to 1 upon f of z minus z naught. Okay. So clearly z is entire. Clearly g is entire. Okay. And mod of zz is less than equals to 1 by r, implies g is constant by Lewis. Okay. And since g is constant, it means f of z is equals to C plus z naught. Okay. So it means that this is a contradiction. Okay. So no need to write this one. So this is a contradiction. Since f is non-constant. And hence f of C is dense in C. Okay. Is it clear? Any doubt in this one? Okay, so let us move towards the next problem. Question, I think it is 6 or 7. This is question number 6. Okay, so it is, so let f be an entire function, and suppose there exists a constant m positive, comma, or positive, and n not greater than equals to 1, such that modulus of, so this is kind of generalized version of Liouville's theorem, m of mod z naught to the power n for mod z greater than r. Okay, so that f is a polynomial of degree less than equals to n naught. Okay, so let us look at the solution. Oh, wait. So since f is entire, so let f of z is basically equals to summation n equals to 0 to infinity a n z to the power n. Okay, and a n is basically equals to fn 0 upon n factorial. Okay, let n is greater than n naught, and gamma is basically your mod z is equals to r. So it's a circle of radius r where capital R is greater than r. Okay, so on gamma, basically we have this inequality, f of z is less than equals to m r to the power n naught. Okay, now by Cauchy integral formula, what do we have? Mod of an is basically equals to 1 upon 2 pi I, which is integral over gamma f of psi upon psi to the power n plus 1 d psi. Okay, which is nothing but, just wait a minute, I have to keep this in charge. Yeah, so this is the thing. Now this is nothing but 1 upon 2 pi integral over gamma f of psi upon psi to the power n plus 1 d psi, isn't it? So this will be less than equals to, so mod an is less than equals to 1 upon 2 pi and integral over gamma mod of f of psi upon psi to the power n plus 1 mod d psi. Okay, so on gamma, what is your psi? This is r to the power n plus 1, so this is 1 upon 2 pi less than equals to f of mod of f of psi is less than equals to m upon r to the power n naught. Okay, so integral over gamma m upon r to the power n naught upon r to the power n plus 1 d psi. Okay, so this will be, so this we can take it out on 2 pi m r to the power n naught upon r to the power n plus 1 integral over gamma mod d psi. And what is this integral over gamma mod d psi? This is length of the curve gamma, which is nothing but 2 pi r. So this is 1 upon 2 pi m r to the power n naught upon r to the power n plus 1. This is 2 pi r. Okay, so this is nothing but, so mod an is less than equals to m upon r to the power n minus n naught. Okay, so basically just see, I have taken n is greater than n naught. Okay, so for every n greater than n naught. Okay, now this one, as r tends to infinity, as r tends to infinity, this right hand side goes to 0. Okay, so inequality involving modulus of differences, can you tell me where can I, inequality involving modules of different, yeah, so there's a good book by Bruce P. Palka. So you can find this integral, so integral over gamma mod dz, or integral over gamma f z mod dz. So Bruce P. Palka, complex function theory. Okay. So as r tends to infinity, this RHS tends to 0. So this implies mod an is less than equals to 0 for every n greater than n naught. So this is basically an is equals to 0 for every n greater than n naught. So this implies fz is basically I is equals to 0 to n naught a I z to the power I. Okay, that is f is a polynomial of degree less than equals to n naught. Is it clear? So we have only used the cos integral formula. Okay, let's just see the last question. So question number 8. So this is basically on the characterization of entire function. So CHAR is characterize all those entire function f such that modulus of f of z is less than equals to mod z to the power 4 upon ln mod z for mod z greater than 1. Okay, so just look at the solution. So see, the idea is same. Gamma is basically r, and where r is greater than 1. So on gamma, fz will satisfy this inequality. Mod z to the power 4 upon ln mod z. Okay, and here also it was okay. So since f is entire, so fz is basically summation n equals to 0 to infinity an z to the power n, where an is fn 0 upon n factorial. Okay, so let n is greater than 4. Okay, so mod an is basically 1 upon 2 pi I integral over gamma f of xi minus, okay, so xi to the power n plus 1 d xi. Okay, so this will be 1 upon 2 pi integral over gamma mod of xi upon xi to the power n plus 1 d xi. So xi is on this curve gamma, so xi is r. Okay, So this is less than equals to 1 upon 2 pi. Okay, and so this is r to the power n plus 1. F of xi will be mod xi. So f of xi will be mod xi to the power 4 upon ln mod xi into mod xi to the power n plus 1 mod of dxi. So this is basically 1 upon 2 pi. So mod xi on this curve gamma is nothing but r to the power 4 ln r to the power n plus 1 d xi. Okay, so mod an is less than equals to r to the power 4 2 pi r to the power n plus 1 ln r into this again 1 upon 2 pi into 2 pi r. So this will be 2 pi r. Okay, so this is nothing but r to the power 5 r to the power n plus 1 ln r. Okay, so this will be 1 upon r to the power n minus 4 into ln r. Okay, so okay, so if n is equals to 4 and r tends to infinity, this is again fine. So here let n is greater than equals to 4. Okay, no need to just take n greater than 4. Okay, so for n greater than equals to 4, this will be positive as r tends to okay, sorry so as r tends to infinity, what we're having, this RHS will tend to 0. So it means that we are getting an is equals to 0 for every n is greater than equals to 4. So what is f? So f is a polynomial of degree at most 3. Nomial of degree at most 3. Okay, so we are done with the today's assignment. This is clear. So basically, so these are the only entire function which have the polynomial. So the characterization is polynomial of degree less than equals to 3, nothing else. Okay. Okay, so we are done with the today's assignment. So we'll meet in the next assignment, week 8. Yeah, so in week 8 assignment, I will talk about something extra regarding the homologous theory of Cauchy integral Cauchy theorem. Okay, so that we will see later. Thank you.